Logic and problem solving. This is kind of the part that everybody hates in algebra because we don't like word problems. We don't like letters mixed in with our numbers. But it's actually the most important part because this is actually how you would use math to solve real world problems or to solve actual like logical issues. So this is going to tie together kind of all the past things that we've been learning in some of these past videos and just see, can we think our way logically out of a tough problem? So the first one I have for us here, this is saying if a squared minus 1 squared is equal to a to the fourth plus 1 plus k, what's the value of k? So what does this number have to be to make this be true? So the first thing that I want to do here is I want to multiply this out. I want to expand this out and just see what does that look like, this first squared term. So I'm going to do that using the box method. I'm going to multiply a squared minus 1, and I'm going to multiply that times itself. So a squared minus 1. And I just want to see, is that going to look anything like this to where I can figure out what k is. So my first step here, I'm just going to multiply a squared times a squared. That gives me a to the fourth. Negative 1 times a squared is negative a squared. And same thing here, this would be negative a squared. And then negative 1 times negative 1 is positive 1. So just combining our like terms here, we're going to get a to the fourth minus 2a squared because there's two of them, and then plus 1. So I want to see kind of what's the difference between this and this up here. If this is going to equal a to the fourth plus 1 plus k from that problem up here. So like let's just look at what we're missing here. I've already got an a to the fourth here. I've got that here. The plus 1, I also have that over here. So really the only thing that's left after we cancel all this out is just that negative 2a squared. So I can kind of tell here logically, just by seeing what I'm missing and what I already have, this value of k, it's got to be this missing piece. It must be negative 2a squared. The next thing we're going to talk about here is called a Pythagorean triple. And you've probably solved problems with the Pythagorean theorem. You've probably solved these back in 8th grade math or algebra 1. But here we're going to talk about a Pythagorean triple, which is just 3 positive numbers that make a squared plus b squared equals c squared, that make this true, that make it work. So any 3 positive numbers that form a right triangle. And what we're going to look at here is just a method that generates Pythagorean triples. So this question here, it looks kind of scary. Maybe it is, maybe it is. It says use the polynomial identity, this thing. Use this to generate a Pythagorean triple. So what I want to do here is I want to just pick any number, x and y. So I want to pick a first number and a second number, and I just want to plug them into this. So let's start with something easy. Let's use 2, and we'll use 1. So we're going to make x2, we'll make y1, just because these are some smaller numbers that aren't too crazy. And all we're going to do is we're just going to plug that into this polynomial identity, this big equation. So doing that, that's going to give me, instead of x, I'm going to use 2 squared. And instead of y, I'm using 1 squared. Right? And I'm just plugging these into that equation. I'm just substituting these in, and we'll see what happens here at the end. All right, so again, we just picked 2 and 1 just because they're small, easy numbers, plugging those into this equation to see what happens here. So let's start simplifying this. 2 squared is 4. 1 squared is just 1. And we'll square that. Over here on the other side of the equals, so 2 squared, again, that's 4. 1 squared is 1. And then over here, 2 times 1. That's just going to be 2 times 2 is 4 squared. So let's just add these together. 4 plus 1 is 5 squared. 4 minus 1 is 3 squared, and then 4 squared. I'm just going to bring that down. These are going to be our Pythagorean triples. So we could square these if you want. 5 squared would be 25. 3 squared is 9. 4 squared is 16. So if I add 9 plus 16, that's going to give me 25. So this is our Pythagorean triple. The 5, the 3, and the 4. And so kind of this algorithm generated that for us. We just picked two kind of seed numbers, 2 and 1. This algorithm generated a Pythagorean triple for us. So let's try the same thing again, but with just 2 different numbers. So for the last one, you use 2 and 1. For this one, let's just switch that out for 3 and 2. So we're using 2 again, but we're going to make the y the 2 this time. So plugging these in, 3 for x is going to be 3 squared plus 2 squared squared. That's going to equal 3 squared minus 2 squared squared, and then plus 2 times 3 times 2 squared. All right, so let's go ahead and simplify this and just see what our triples are going to be here. 3 squared is 9, plus 2 squared is 4. Bring all this down. 3 squared is going to be 9, minus 2 squared is 4. And then over here, 2 times 3 is 6, times 2 is 12. All right, and then for our last step, we're just going to add these together, subtract these apart. 9 plus 4 is 13 squared. 9 minus 4 is 5 squared. And then just bring this down. This is going to be our Pythagorean triple. And again, we can check this if we just do 5 times 5 is 25. Plus 12 times 12, that's 144. If we add 15 plus, or 25 plus 144, if we add those together, that's going to give us 169, which is 13 squared. So this is going to be our Pythagorean triple. 13 squared is equal to 5 squared plus 12 squared.